Hello. Hello, hello. Thank you all for being here. Goodness, again. Excuse me. Thank you all for being here. Sorry, we are a bit late tonight. Originally it was 1:30. And then it was after 1:30. And I was like, shoot. Because I like to be kind of punctual with, or like accurate to what I'm scheduled for the most part. And so I don't like being late, like after I schedule a thing. If I'm early, it's a little different. But I was late today, and so I rescheduled it. It was after 1:30 when I rescheduled it for 2:30, and so technically I'm early for the 2:30 schedule, but I'm late for the 1:30. So I apologize for being late on that. But excuse me, goodness me. Yeah, we're pretty much just going to jump right in since we're a bit later tonight than usual. Let's see how long the exercise is. Wait.
Hello and welcome.
Oh, is this what we did last time? I think this is what we did last time. Hold on a second. Let me check the last. Let me check the last thing. Yes, it is. Mm-hmm. Oops. Okay, yeah. What does the word continue do? It skips the iteration of the loop. Or skips to the next iteration of the loop. Here we go. Here we go. All right. Oh, and the little check. I saw there was a check mark up here for the last one. There's no check mark on this one, so that's helpful. We'll just kind of go through this. We'll see, kind of feel it out. If we need to spend time on this and only do this one, we will. But if not, we'll just take it as it goes.
Hello and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now, we've been talking about
programming, algorithms, a set of rules or steps used to solve a problem, data structures, a particular way of organizing data in a computer. This is going to be interesting. I don't have my light on. Hold on a second. I thought I'm like, my face looks oddly lit. Boom. There we go. That's a little more regular. There we go. But yeah, this is going to be interesting because data structures have been something that's kind of confusing to me. The concept of it. Oh, and this is also what's causing me to be weirdly lit. There we go. Cool.
algorithms. Algorithms are the concept in computer science of using the programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and the simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure.
What is not called a collection? Most of our variables have one value in them. We put in a new value in the variable. The old value is overwritten. Makes sense. Yeah.
That we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it. And then an assignment statement, you know, sticks a 2 into X, and then 2 is in this little cupboard. And then it goes to the next line, and then 4 goes into X, and so the 2 goes away and the 4 is there. Now, a key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable.
Oh.
So when we move to collections, collections are more like suitcases.
A list is a kind of collection. A collection allows us to put many values in a single variable. Okay. Oh, a collection is nice because we can carry all many values around in one convenient package. Friends equals Joseph, Glenn, Sally. Carry on equals socks, shirt, perfume.
We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while. Every time we use one of these square bracket syntaxes in earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list constant, and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these bracket structures.
List constants are surrounded by square brackets, and the elements in the list are separated by commas. A list element can be any Python object, even another list. Well, dang. A list can be empty. Print 1, 24, 76. Print red, yellow, blue. Print red, 24. Oh, so it can handle strings and... Well, of course, it's taking this as strings, I'm sure. Well, yeah, no, it is. Oh, crud. Print 1. Oh, so it's just reading that as... Okay. Print. Oh, yep. That's just a blank thing.
With square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 1, 24, 76 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different positions in the list. So red, 24, 98.6. A 3-item list with a string, an integer, and a floating point number. And while we're not going to use this...
I thought I would take it as a string, but I was mistaken. It is. They are different types. Integer, float, string. Not all strings. I mean, they aren't all strings, is what I'm saying.
This too much for now. This outer list is a 3-item list, and the second item is another list. So this is kind of alluding toward what we'll do when we start talking about data structures, and that is we have a structure and then we have another structure inside of it, and sometimes this can get quite complex.
Wow.
And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. We can put lots of things here. We can put file handle here, we can go through the file, we can put a string there, we can go through the characters in the string, and in a list. And the iteration variable then goes through the successive elements of the list, and that's why this prints off y4, 3, 2, 1, and then the loop is done and it prints out blast off. So we've been using them, and we've been actually iterating through lists with for statements all along. So the the for statement, has been something we use with lists, and when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable, friends is our list variable, and so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out, Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing, to have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists.
Looking inside of lists, just like strings, we can get at any single element in a list using an index specified in square brackets. Oh. Just like strings, we can get any single element in a list using an index specified in square brackets. Joseph is 1, Glenn is 2, Sally's 3. Interesting. Okay, before we do this, I'm going to be right back. Bear with me. Okay. We are back. Sorry about that. All right.
Thing is, when you put more than one thing in a data structure, you need to get them out. And so lists have positions, they maintain order, and so the first thing in the list is the sub-0 position, sub-1, sub-2. Just like strings, they're zero-based, just like European elevators, they're zero-based. So if we take a look and we say, oh, friend sub-1, that's how I read that, the little square brackets, when you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2, and so that's what prints Glenn out in this.
I was a little confused by what he was saying with the 0, so I think I get it.
Particular thing. Now,
lists are mutable. Strings are immutable. We cannot change the contents of a string. We must make a new string to make any change. Lists are mutable. We can change an element of a list using the index operator. Fruit equals banana. Fruit O equals wait. Okay, so that's a string, right? Fruit O, fruit sub O, sorry, is B, which is just trying to make it lowercase, trying to change the string, but then you get a traceback. String does not support item assignment. X equals fruit dot lower, which, yeah, so you can make it lowercase that way. Lotto equals, okay, this is what we're talking about. Lotto equals 2, 14, 26, 42, 63. Print lotto. Lotto 2, which is 14, equals 28. Print lotto. Oh, might be, because it's 0, 1, 2. So it changed to 26, 28. So 2, 14, 28. Cool. Wow. Oh, crap. That can get complicated, huh?
Lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has three things. You can change the thing right in the middle if you want. To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit, well, fruit sub 0 is a capital letter B. Could we imagine for the moment that we could change fruit sub 0 to lowercase b? Well, the syntax would be how you would do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in X, and that's how X becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that with a list, though. Here we have a 5-item list, 2, 14, 26, 41, and we're going to do the sub 2 position, and the sub 2 is 0, 1, 2, so that's that one right there, and we're going to assign a 28 into it. So that 28 is going in here, going to wipe that out and put 28 in. So we can do item assignment in lists by putting a bracket syntax on the left-hand side to say, don't just put it in the variable, put it in this position within the variable. So that's what
do you mean on the left-hand side?
Assignment in lists by putting a bracket syntax on the left-hand side to say, don't just put it in the variable, put it in this position within the variable. So that's what
I think it's the left-hand side of the assignment variable. The assignment, okay. I think.
That's doing. And when you print that out to 28, everything else is unchanged, meaning the whole list is there. There could be 1,000 items in the list, and then you're changing the second one. We have a function called len.
We know len. How long is a list? The len function takes a list as a parameter and returns the number of elements in the list. Actually, len tells us the number of elements of any set or sequence, such as a string. Greet, hello, Bob. So len will just give you the length of anything. As far as I know, right? Greet equals hello, print len greet, 9. X equals 1, 2, Joe 99, print len X 4, because it's 1, 2, 3, 4. So len does not go by the position, which is kind of weird, because if you were to go by the index, if you want to call it, I think that's what it's called, it'd be 0, 1, 2, 3. But printing it, like the length of it, is 1, 2, 3, 4.
Using this len function all along to take a look at how long strings are. It counts the number of characters in the string, so that's a 9-character string. If we have items in a list, Len tells us how many items there are. It's not like how many characters there are, it's the number of things. And each thing doesn't have to be a number. It could be a number, a string, or even another list. And len is the way to say, hey, how many things are in there? There's a function.
I think we've used range as well, right? What? Oh, no, we haven't actually spelled out range. Using the range function. The range function returns a list of numbers that range from 0 to 1 less than the parameter. We can construct an index loop using for and an integer iterator. Print range 4. Okay, so it's going to be, oh, interesting, is 1 or 0, 1 to 3, and then friends, Joseph, Glenn, Sally. Print length friends 3, 1, 2, 3. Print range length friends 1, 2, 3. No, I'm sorry, 0, 1, 2.
That returns a list of numbers, and we use it, as we'll see in a second, to construct specialized loops to go through lists. So let's take a look at this range function just for a minute. So range takes as its parameter the number of numbers that you want returned. So I'd like a 4-item list with the numbers 0 up to but not including 4. And so it just turns out that that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2, as compared to the the definite loops that go each way, go through each one. And so it's a common thing to say, okay, we know how many.
That's confusing. I don't know about that. How is this useful for constructing for loops?
Up to but not including 4. And so it just turns out that that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2, as compared to the the definite loops that go each way, go through each one. And so it's a common thing to say, okay, we know how many things are in this list. There are 3 friends, and if I combine range and len, so I take len friends, which is 3, and then I take range sub 3, I get 0, 1, and 2. And so the interesting thing is this 0 corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need.
Hold up. Wait, hold up. Print length friends 3. Oh, because it's 1, 2, 3 length. Then ranging makes it 0. It starts at 0. That's why it's 0, 1, 2.
Need to go through a we need to go through an array and remember what position we're at.
What?
Oops. Especially when we need to go through a corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need to go through an array and remember what position we're at.
Friends, Joseph, Glenn, Sally for friend and friends. Print Happy New Year, friend. Happy New Year. Da, 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 da. For I. Oh. Hold on a minute. For I in range, length, friends. Friend equals friends, I. Oh my gosh. For I in range, length, friends, friend equals friends, I. So Oh my gosh, this is like the most confusing thing I've seen so far. Let's look at this one. Friends equals Joseph, Glenn, Sally, print length friends. 3, print range length friends. 0 and 2, yeah, that makes sense. For I in range. I hope he explains this, because oh my goodness. Print Happy New Year friend. Friend equals friends. I don't understand. This bit right here is what I don't understand. For I in range. Like, hopefully he explains it.
And so here's just an example of 2 different loops. This is a for loop that's just going to go through whatever's in this list. So friend is just going to take on the successive values, and so it's going to print out these 3 things just as you would expect. And if you don't need to, while you're going through the loop, know the position, your relative position from the top in the loop, that's okay. But sometimes you want a little more sophisticated loop, and instead you want to be able to loop through where you know the position. And so what we do instead is, instead of looping through the list itself, we do range len friends,
Okay.
which gives us 0, 1, 2.
Fair.
And then I takes on the successive values 0, 1, and then 2. So this loop is going to run 4 times, and I is 0 the first time. And we might even just look up the value inside that sub-0 value, so we get Joseph the first time, so prints out Happy New Year Joseph, goes, and I becomes 1 now, and so it gives us Glenn, and that prints out, and away you go. So if you look at these 2 loops,
Okay.
if you look at these 2 loops, they really do the exact same thing. The only difference is this we allowed the for to find its way with the iteration variable through, and here we created our own I variable that went through the positions, and they're dense. There's no gaps in here, so it's 0 through 2 that it goes through. So these 2 are equivalent. There will be times when you'll want to use one in the other. I tend to prefer the first one because it's prettier as long as it works for me. So that gets us started with loops. We'll be back in just a bit. Works for me.
Cool. Yeah, no, I like this one more too. For I in range. So range length friends gives us 0, 1, 2. That's what it like creates. Okay, so this kind of for I in range length friends. 0, 1, 2 in this case. Friend equals friends I, which chugs it through the 0, 1, 2 of friends. 0, 1, 2, 0, 1, 2. Print Happy New Year friend, which is this. Happy New Year friend. Or friend, which is friends I. A bit confused by this. Friend equals friends. For I in range, so 0, 1, 2. Friend equals friends. I feel like the friend, like the fact that it's called friends is what's tripping me up here. For I in range, like friends. Friend equals friends. For I in range like the friends. Range like the friends. 0, 1, 2. Friend equals friends. I. Yes, that's what it iterates through. It iterates through friends, which is except because of the whole range like the friends thing. That's why it does the 0, 1, 2 thing, which in this case is just Joseph, Glenn, Sally. Happy New Year. Okay, I think I understand. So say Happy New Year friend, which friend iterates through friends. 0, 1, 2, Joseph, Glenn, Sally. Happy New Year, Joseph, Glenn, Sally. Oh, my word. What is the value of x after running this code? Fruit equals banana. X equals fruit 1. Ooh, cheeky. 0, 1. It's going to be A, my man. Happy, happy, joy, joy. Okay. So we got another one without an exercise, which is good. Which method is used to add an item at the end of a list? It's going to be append. I just know it's going to be append. It has to be append. Could be wrong. But let's watch this one. I think this is going to be our last video for this stream. I know we haven't actually done any actual coding, but we'll just do, it'll be a video night, and call it a day. Call it a day. Well, we might mess around here. Let's just we'll do something.
Hello. I'd like a 4-item list.
Here we go. Y'all see that? Yep. Oh, frick, I can't see. Here, we'll do this. Hey. Hey, so now we can just we'll do this just to kind of get our toes wet. Superhero equals, do brackets. Is it brackets? It is brackets. Iron Man, Batman, Spider-Man, Hulk, right? For hero and superhero, print. Oops. Oh, let's just, okay, hold on. Print your, how did they do the thing? Your, my favorite superhero hero? Am I thinking right about this? I did that. Oh. No, that. Oh. My bad. This was included in the... There we go. There we go. You're my favorite superhero. Iron Man, Batman, Spider-Man, Hulk. So then if we do... print len superhero, it'll be 1. I'm sorry. What on earth? Did I do len right? No? Yeah? I literally did it right, but what? It shouldn't be 1 though. It shouldn't be 1. Just gonna copy. Oh. Hold on. You feel me? Oops. Now it should be 4. Man, parentheses, like quotes are just, they're gonna be the death of me. Print range len superhero. That'll be 1, 2, 3. What? Zero. Is this like, am I going crazy? Print range len yeah, no, that's right. Okay, so I mean, forget about it. Let's forget that for now. We'll just for I in range len superhero hero equals superhero bracket I. Print your my favorite hero superhero hero. That way it'll iterate. Yep. Hey. My favorite hero, Iron Man, Batman, Spider-Man, Hulk. 0, 1, 2, 3. 1, 2. I just don't get this though. What if it was just for print range, got rid of the length. Huh. Interesting. So I need the length with I can't do range with that. Okay.
And if you don't need
I'm just confused by this. I'm hung
Hello.
up on
9498.6
on length. Here, let's try something. Print range 4. So we should get exactly. It's not exactly like you said. Zero one. Oh my gosh, that's kind of the worst. Is that just the age of this? I don't know what to tell you. I mean, we literally copied it, right? We did. I'm all like second guessing, doubting.
there's a
Print. Yeah, I don't know. Sorry for checking that. Like OCD checking. Sorry. That's like the doubt, you know, the OCD doubting. Like, oh, did I really? Is something a list? All right, last video. Here we go.
Okay, so we've taken a look at loops, and now we're going to just take a little, a bit of a look at some of the operations.
Concatenating lists using plus. Oh, we can use. Oh, we can create a new list by adding two excuse me. We can create a new list by adding two existing lists together. 1, 2, 3, 4, 5, 6. C equals A plus B. Print C. Oh, so it doesn't add the integers. It just throws 1, 2, 3, 4, 5. Oh, great.
That you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators, and the plus can add strings and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding?
I'm sorry. Back it up a little bit.
Similarly works. Plus can add strings and it can add numbers. It can add floating point numbers. As we'll soon learn, object-oriented approach to its operators.
I'm just starting over. I'm sorry.
Okay, so we've taken a look at loops, and now we're going to just take a little, a bit of a look at some of the operations that you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators, and the plus can add strings and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding? And in the case that I'm adding the list 1, 2, 3 and the list 4, 5, 6, it concatenates them together. In this way, it sort of functions like a string, and so we get 1, 2, 3, 4, 5, 6. It's just concatenate this list to another list. And it doesn't change A or B, just like in any kind of assignment statement. Calculations on the right side don't change the variables, and they produce a new variable and then assign that into C.
Excellent.
You can also use list slicing, and it's easy to remember. If you remember,
Lists can be sliced using colon. Remember, just like in strings, the second number is up to but not including. T equals 9, 4, T 1, 3, so 0, 1, 2. What? 0, 1. Oh, but not including 3. My B. So that's 3. So 0, 1, 2, 3. So it's only got 0, 1, which is 42. 0, 1, 2, which is 12, but not 3. Everything before 4. 0, 1, 2, 3. 9, 4, Yep. T, everything after. Is it including 3? 1, 2, 3. Oh, wait, no, sorry. 0, 1, 2, 3. Yes, it is. So it's only the second number. The whole dang thing. The whole dang thing.
remember how strings work, list works exactly the same way. So it's, of course it's a little tricky. The first number is the starting position. They start at 0. So 1 is right there. So it's the 0 position, the 1 position. Start at 1, right? But go up to, but not including 3. There's 1, 2, 3. So this goes up to, but not including 3. And that's why we get 4112 out of that. So up to, but not including. I'll just say that over and over and over again. If we do, you can leave the first part out. You can leave the first part out here, and you can say, oh, up to but not including 4. So that starts at the beginning, goes up to but not including 4. And so that's how we get that piece right there. We can say start at the position 3, 0, 1, 2, 3. Start at position 3 and go to the end. Now the fact that the number 3 is in here is sort of irrelevant. 3 to the end is those 3 numbers. And then you can do the whole list with slicing as well. Again, these pretty much are the exact same examples I used when I was doing strings. They're pretty much the same. There's a number of different methods, and you can look up all the documentation in list. I often just use the dir command to remind myself of them. Append will look at.
X equals list. Type X. Type is list. Oh, because it's just been defined as a list. X, append count, extend, index, insert, pop, remove, reverse, sort.
Count looks for certain values in the list. Extend adds things to the end of the list. Index looks things up in the list. Insert allows the list to sort of be expanded in the middle. Pop pulls things off the top. Remove removes an item in the middle. Reverse flips the order of them, and sort puts them sorted order based on the values. So let's look at a couple of these.
Oh, we were right. Building a list from scratch, we can create an empty list and then add elements using the append method. The list stays in order. New elements are added at the end of the list. Stuff equals list. Stuff append. Stuff dot append. Book. Stuff dot append at 99. Print stuff. Book. Oh, because start off is empty. Book 99. Oh. Stuff dot append cookie. Print stuff. Book 99 cookie. Cool.
So if we build a list from scratch, we have a way to ask for an empty list. There are a couple different ways to ask for an empty list. We could use just 2 square brackets next to each other. But this is a form we call the constructor form, where we say, hey Python, make a list. In this case, the word list is like a reserved word to Python. It's really a reserved class, but say list parentheses says make me an empty list, and then assign that list into stuff. So stuff is now it's a list object, it's of type list, but it has nothing in it. And then we can call the append method, stuff.append, and stick book in. And then we say, oh, and that knows how long, the stuff knows how long it is, where the end is, and how to add something to it, and then add a 99 to it, and we print it out. We got book and 99, reminding ourselves that lists, while they're often the same types of variables, same types of values in the various positions in the list, it doesn't always have to be that way. Then we say, oh, we'll stuff.append cookie. You can keep on going, and then we end up with three things and the cookie. We have an in operator. It works pretty much like the in operator in a string. Is 9 in my list, and that's
something in a list. Python provides. Hold on.
We have the values in the various positions in the list. It doesn't always have to be that way. Then we say, oh, we'll stuff.append cookie. You can keep on going, and then we end up with three things and the cookie.
Python provides two operators that let you check if an item is in a list. These are logical operators that return true or false. They do not modify the list. Sum equals 1, 9, 21, blah, blah, blah. 9 in sum. So it's like, is 9 in here? Yes, it is. 15 in sum? No, it isn't. 20. Wait. Is 20 not in sum? Yes, it is not. It's complicated, man.
We have an in operator. It works pretty much like the in operator in a string. Is 9 in my list? And that's pretty simple, and the answer, of course, is yes, 9 is in my list. Is 15 in my list? Looking through, no, it's not. 15 is not in my list. And then there's the not in operator. You can think of that as kind of like one operator. Is 20 not in the list? And the answer, since it's not there, is true. And so that's a way to just, it's kind of like starts with or in for strings, same kind of stuff. Lists are in order.
Oh my gosh. Lists are in order. A list can hold many items and keeps those items in the order until we do something to change the order. A list can be sorted, i.e. change its order. The sort method, unlike in strings, means sort yourself. What? How? Friends equals Joseph, Glenn, Sally. Friends dot sort. Print friends. Oh, it's in alphabetical. Print friends 1. Oh, that's the worst. Oh, no, it actually doesn't. It does not change the list. Because if it's still Joseph, right? It's still in here. There's the list. It's just that you can make you can print a new list, and then that list can be sorted when you print it. Before you print it. I'm making it more complicated than it needs to be. We're going to continue.
Order, and they're sortable. And so this is something that we take good advantage of. A lot of what computers want to do is sort stuff. Look all these things up, append them, and then get them sorted. And so there is this method inside of list that's just the sort method. So here we put three values in 0, 1, 2 position, 0, 1, and 2, Joseph, Glenn, and Sally. And then we tell the list to sort itself, and then we print it out. Now this is actually sorted the list in place, which is different than upper and lower, because if you remember, strings are not mutable, but lists are mutable, and so you say, hey, just sort yourself. Okay, and so just sort yourself, and then it sorts it, and then it's in alphabetical order, Glenn, Joseph, and Sally. I happen to be clever. I only put strings in there, and I put my uppercase and lowercase in a very consistent pattern, but the list is changed. And if I look at list sub 1, that is the second item, which is Joseph, that prints out right down.
Oh gosh.
There.
I got that wrong. 0, 1, 2. I thought it was 1 up here. Uh, hmm. Can we just... Hold on a second. We're just going to duplicate this. My hands are dry. Need to put some lotion on. Friends. Whoops. Friends. Oopsies. Hit it twice. Glenn, Joseph, Sally. Glenn, Joseph, Sally. Print. Friends. Two. So it should be, okay. Glenn, if it's up here. Sally, if it's like this one. Okay. All right. So it is sorted. Cool. Okay.
Is the second item, which is Joseph, that prints out right down there.
Built-in functions and lists. There are a number of functions built into Python that take lists as parameters. Remember the loops we built? These are much simpler. Nums equals print length nums 6. Print max nums. Oh my gosh. Yeah, no crud, dude. The loops. Like the is greater than. Oh my word, wow. Print max nums 74. Just spits it out right like that. Minimum num 3. Sum? There's sum as well? Print sum divided by, bro, that gives the average. Come on, man.
There's a whole bunch of built-in functions to help manipulate lists. The other things I was showing was sort is a method that's part of lists, but there are other functions that take lists as their arguments. We already talked about the len function. Tells you how many items there are. There is pretty obvious max. It says go through and find the largest. Min, go through and find the smallest. Sum goes through, adds them all up. And we can say let's do average by taking the sum of all of them and dividing it by the length. And you might think to yourself, oh wow, I wish we'd have known this a few chapters back when we were having to write all those loops to do max, min, sum, largest, smallest, etc. You can kind of think in your mind that inside each one of these functions is a loop that does pretty much what you did in those chapters. And part of the reason we did that back then, even though these things were here, was they're kind of easy loops to understand. And so those are there. And basically they're a lot.
Hold on a second. Total equals 0, count equals 0, while true, put INP equals input, enter number, if INP. Oh, so this is just average equals. Num list was list while true INP. Value equals float. INP. So it just turns this into a float. Numlist.append value. Oh my gosh, so this is just an easier way. So this is just enter number until you hit done. Average equals sum. Oh, that just does it right there. Sum num list adds it all up. Oh my gosh, man. Divide by length num list, so it's whatever. Oh my word. Print average. 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 Dang.
Allows two different ways of building loops to do the maximum minimum. Now, it's not necessarily all that much easier to to do something using these, because you either can do them the old way, or you can make a list and then use these functions. So let's take a look, and I'll just say that these two bits of code are doing the exact same thing. And what they are is they're implementing a program that's going to repeatedly ask for numbers until we type the word done, and then it's going to compute the average and tell us what they are. And so using sort of the stuff from the loop chapter, we start with a total variable and a count variable, set them to 0, and then we read a number, we check for done to break out, but then we convert it to a floating point value. And then we say total equals total plus value and count equals count plus 1. And so this is going to run over and over and over again, however many times we're going to do this. And then it's going to pop out, and when it's done, it's going to have this value of total. The running total will become the overall total divided by count, and it'll print the average out. Okay? And so that's kind of how we would have done this before we knew how to do this with lists. Now, let's take a look at the other one. In the other one, we say, let's make an empty list. Remember, this is that constructor syntax that says to Python, make me an empty list and assign the empty list. It has nothing in it, right? But it is a list, has nothing in it, into the variable num list. Now we're going to write another loop. This part here is the same, these 3 lines. Read the number, if it's done, quit, and convert it to value. But instead of doing the actual calculation right now, what we're going to do is just append it to the list. So the list will start out empty, then the 3 will be in the list, then the 9 will be in the list, then the 5 will be in the list. So we're appending, each time through the loop, we're appending into the list. So we're just growing the list every time I read it, then the 5 will be in the list.
So append value. Okay, yeah. So that just adds the input, which has been turned into a float, to the num list.
So we're appending, each time through the loop, we're appending into the list. So we're just growing the list every time I read a value, instead of actually computing something with the value that we've got. So in either case we get value, and in one case we append it to the list. And then finally it finishes, the break happens, and then we just say, oh, hey, Python, sum up everything in the list, add these 3 numbers together, and then divide it by the length of all those things, and you'll have the average. And so these 2 things give us exactly the same output. Now there is one difference. If there was like 1 million or 1 billion numbers, they actually have to all be stored in the memory simultaneously, whereas here it's actually doing the calculation of the billion numbers and not using up so much memory.
Wait, what?
Most of the things that are 1 billion numbers, they actually have to all be stored in the memory simultaneously, whereas
Right. That makes sense.
here it's actually doing the calculation of the billion numbers and not using up so much memory.
Oh.
Here it's actually doing the calculation of the billion numbers and not using up so much 1 billion numbers, they actually have to all be stored in the memory simultaneously, whereas here it's actually doing the calculation of the billion numbers and not using up so much memory.
I get that, actually. So, like with this one, like you said, you're just adding to the list. So if you have like a ridiculous number of numbers that you're entering, enter a number, like he said, 1 billion numbers. You have a list that's 1 billion like elements long. Once you hit done, then it calculates the sum and length of all that, like the billion list at that point. But with this, it does it as it's going. So at the end of the day, you still have like 1 billion elements that you've dealt with. But with this one, is doing it along the way instead of saving it for the end.
For most of the things that you're going to be doing, the difference in memory, there is a difference in memory. This one here uses more memory, but I can't draw very well. More memory. It uses more memory, but it doesn't really matter by the time it's all said and done. And so for you, the difference between these things is not all that significant, but it's important to understand that they're just two techniques to accomplish the same thing with lists.
Cool. Love it. We're learning. We're doing it. It's happening. Which method is used to add an item at the end of a list? Append. Append. Raise the roof. Oh, and we have an exercise. What does n equal in this code? Words equal his emails. Pieces words dot split. Parts equals pieces. 3. Oh my gosh. So the split doesn't do anything. I mean it does, but it's not for what the question is asking. Pieces. Oh my gosh, excuse me. Whew. I think we'll need to wait on this. I mean, obviously we will, but because I don't know what does that get split? The dashes out. Parts 1. I don't know. But that's going to do it for now. Thank you guys so much for watching. Another hour stream in the bag. Leave a prayer request below. I'd love to have the opportunity to pray for you guys. Please like and subscribe if you want as well. And love God, love people. And that is going to do it for tonight's stream. I'll catch you guys tomorrow.